Okay, so if a vectors come in a diagram question, there's a bit of counting squares. So there's a bit of counting squares. So what do I mean by that, right? So for example, they tell you that AB is vector P. So when I look at vector P, we don't just look at it like this. You will look at it like how many squares. So it will help you in both part of the question. So to me, right, vector P is made from 3 squares. Can you see? It's like, like playing Lego bricks like that. Like you put 3 tiles and then the diagonal is vector P. So you got to see vector P in terms of, that every 3 square horizontally like this will make up a vector P. So which also means that, let's say here, it's also a vector P because it's also three tiles. So every 3 square actually create a vector P. So this is what you need to know first. So when you look at a vector, you don't just look at the arrow, look at the squares that make up of it. So here, 3 tiles will make up vector P. So if I do the same thing for this part, AC. So AC is vector Q. So to me, when I look at Q, is a tile of 4 squares. Okay, so is a tile of 4 squares. Okay, so and you need to take note of the direction. So there's a lot of 4 squares. You can take a look. So for example, let's say this corner, I got 4 squares, right? This part will be a vector Q. Okay, so every 4 squares in that manner and downward direction will form a vector Q. So that is your idea first. So once you have this idea, then we can do part A first. So part A, you think of it as like this one, there's 2 journey. So you do this first. So from A, you go 3 square first, can see? So these are 3 squares, right? So you will go to B first. So you stop at B already. Then you need to do this. You do this from B. Okay, so once from A, you do vector P. How do you do vector P from A? You count 3 squares. Okay, then I need to do this part from the minus, this one is minus 1.5 Q from B. So this one is positive direction. The negative direction will be like this. So can you see this is also 4 square? So this is 4 square. So this part is minus Q. I will need another half Q. That means I need another half Q. Where do I get another half Q? I will count another 4 squares, but I only move until here. So this part is the minus half Q. So every 4 square will give you a vector Q. But if you don't want the full vector Q, you still can count the 4 squares, but you don't go the full one. So this will be my X. So you visualize it as this is like taking a train. And after take a train, you take a bus. So there are 2 journeys. So X will end up being there. Okay, so no matter what, right, vector P comes from 3 horizontal square. Vector Q comes from 4 square. But whether is it opposite direction or what, it will still be 4 square. So 4 square will form a vector Q. Okay, so that's how we get the point X. Okay, the next part, we are also going to play around with the horizontal 3 square and the 4 square. So every question can be different, but when you look at vectors, you look at how many tiles or how many square make up that vectors. Okay, so the next one, right, we wanted AD. Actually, when I do this kind of question, I also won't know. So I will usually play around with it. So the obvious one is I play around with this one first. So this one is 4 square. I am going to try another 4 square first. So I'm just trying in terms of the square. So I try 4 squares, I try 4 squares. After I try the 4 squares, right, I realized that this part is the 3 square. So remember just now I said every horizontal 3 square will give you the vector P. So this part gave me the vector P. And this part is a 2Q. So essentially AD is made out of 2Q and P. So you need to do a bit of trial and error, but your trial and error must be based on the square. So here I am playing around the 4 squares, and then the 3 horizontal squares. So you got to process the vectors. If a grid is given to you, you count the number of squares to help you.